Hi, welcome back. In the previous video you saw how to solve equations of degree 1 and 2. In this video we look at equations of the form p of x equals 0 with p a polynomial of degree 3 or higher. Let's first see if we can already say something about solutions of this equation without actually solving it. In the video on polynomials in week 1 you have seen that the graph of a polynomial of degree n intersects any line in at most n points. So the graph of p intersects the horizontal axis in at most n points. This means that the number of solutions of p of x equals 0 is less than or equal to the degree of p. For example, in the picture you can see that the equation x cubed minus 7x plus 6 equals 0 has exactly 3 solutions. Now suppose that the polynomial p has odd degree, that is, p is of the form an times x to the power n plus lower degree terms, with n an odd number. Let us assume that an is positive. We know that for x far away from 0 the polynomial behaves like an times x to the power n. So p of x is positive if x is a very large positive number, and p of x is negative if x is much smaller than 0. Since a polynomial is a continuous function, it has the intermediate value property which guarantees that p becomes 0 somewhere, as you can also see in the graph. This means that the equation p of x equals 0 has at least one solution if the degree of p is odd. Note that we can of course use the same arguments for negative values of an. If p has even degree, it can happen that there is no solution at all. For example, the equation x to the power 4 plus 1 equals 0 has no real solutions. Okay, let's now try to solve the equation p of x equals 0. You may be surprised to hear that if p is of degree 3 or 4, there are formulas to solve this. However, they are much more complicated than the quadratic formula. The question is, if we don't want to use these complicated formulas, can we still solve equations of degree 3 or higher? And yes, in some cases we can. We want to factorize the polynomial, but most of the time this is too difficult. However, sometimes we can guess a solution which gives us at least one factor of the polynomial we are looking at. For example, we want to solve x cubed minus 7x plus 6 equals 0. In this case, it is not hard to see that x equals 1 is a solution. I claim that this means that the polynomial contains a factor x minus 1. That is, the polynomial can be written in the form x minus 1 times a polynomial of degree 2. To find the coefficients a, b and c of the unknown polynomial, we expand the left-hand side and then we compare the coefficients with the original polynomial. We start with the coefficient of x cubed. This immediately gives a equals 1. Next, we look at the coefficient of x squared. This gives b minus a equals 0. We substitute a is 1 in this equation and then we find that b is equal to 1. Finally, the coefficient of x gives us the equation c minus b equals minus 7. Substituting the value of b here, we find that c is equal to minus 6. We can also compare constant terms on both sides. This gives us the equation minus c equals 6, which indeed corresponds to the value of c that we just found. So we factorized our polynomial as x minus 1 times x squared plus x minus 6. Now we continue solving the third degree equation with the factorized polynomial. The factor x minus 1 gives the solution x equals 1, which we already knew, so it remains to solve the second degree equation x squared plus x minus 6 equals 0. And we know how to do this. In this case we can factorize as x plus 3 times x minus 2. And then we obtain two more solutions, x equals minus 3 and x is equal to 2. Let's summarize what you've seen in this video. We consider the equation p of x equals 0 where p is a polynomial. If p has degree n, then there are at most n solutions. If n is odd, there's at least one solution. And if n is even, there might be no solutions at all. For solving p of x equals 0, you first try to factorize p, and if you don't see how to factorize, try to guess a solution A and extract a factor x minus A. Note that there is no guarantee that this always works. In the exercises you can practice solving equations involving polynomials. Good luck!